ladies, this is lesson 5.8. It's about analyzing graphs of polynomial functions. So we're going to use intercepts to graph our polynomial functions. And if you remember from quadratics, we had a minimum and maximum. Well, if you think about what a cubic or a quartic function looks like, we have several areas of peaks and several areas of lows. So we have a couple new vocab terms, and the first one is local maximum, and that's the turning point. So this graph is a cubic graph that you can see right here to the right, and this point is the local maximum. It's not the maximum of the whole graph, because as you can see, like over here, for example, this point is clearly higher, but this point, this local maximum, is the highest point compared to its surrounding points. And then we also have local minimum. So same is true with the local minimum. It's not necessarily the minimum of the whole graph, but it's the lowest point looking at all of its surrounding points. So we've been talking about zeros, factors, solutions, and intercepts. And if the polynomial function is set to 0, then k is anything that solves that makes that statement true. So k is a 0 of a polynomial function. That means that x minus k is a factor. That means that k is a solution when it's set equal to 0. And it means that that's the point where y is 0. That's the x, k is then the x coordinate. So if k is a real number, then that's where the graph intersects with the x-axis. So in this next problem, we're going to use x-intercepts to graph a polynomial function. So we're going to look at what the zeros of this function are. So the first step is to find the zeros. So in this case, we have a 0 of -1, and we have a 0 of +4. Now, -1 is a repeat solution, so it's not actually going to go through that point, but it's going to touch it. So -1 and +4. Let's graph those 2 points, or plot those 2 points. And then we want to look at some points between those intercepts. So the zeros are the x-intercepts. So now we want to plot points between and beyond intercepts. So let's look at a few points, a few x coordinates, a few y coordinates. So we'll do -2 because that's beyond our intercept, and then we want to do something in between those. So maybe 0, maybe another one somewhere in there, maybe +2, and then we have 4, so let's also do 5. So before we actually plot these, let's think about what our end behavior is going to look like. So if we imagine our end behavior, here we have x squared, here we have x. So that's going to be an odd degree. And then here's our leading coefficient. It is positive. So our end behavior is going to look something like this. So as we plot our points, that's what our end behavior should look like. That's how we know we have enough points plotted. And again, the more points you plot between your intercepts, the more accurate your graph is going to look. but make sure that your end behavior correlates to what you imagine it should be. So we're going to take these x coordinates and we're going to plug them into our function to get our y coordinates. So I'll do the first one, but beyond that, it's just substitution. So 1, 4, -2 plus 1 squared times -2 minus 4. So I'm just substituting my x values in here. So f of x or my y is 1/4 times -1 squared times -6, which is 1/4 times 1 times -6, which is -6/4, which is -3/2. If I choose 0, I'm going to get -1. And when I choose 2, I get -4.5. And if I choose 5, 9. Alright, so now I'm going to plot those other points. So -2 and -3/2, 0, -1, 2, -4.5, and 5, and 9 is way up there. Alright, so I know that -1 is a repeat solution, so I'm not going to go beyond that. So here's what my graph will look like. Something like this. So it does resemble the end behavior that I thought I would have, which is linear with a positive slope. And so after I've got all my points, and I already did this, but you will draw your graph. So here's another similar example. We're graphing the function. So first, let's find our zeros. And we'll plot those. So zeros here, +2, -1, +1. So 2, 1, -2. We don't see any repeat zeros, so all of these are going to go beyond the x-axes. Next, we're going to plot points between and beyond. Our intercepts for zeros. So you can choose some x coordinates. And use substitution to get your y values. So I'm going to choose one that's smaller than my lowest zero. And then something in between my two zeros, maybe a couple points. Something between my last two zeros, so between 1 and 2, and then something beyond 2. And you can just use substitution. I'm not gonna do that on screen. But if you substitute -3 in for x, you get -80. You do, oh, I meant -1, that should be -1. So if you do -1, your y value is 0. You do 0, your y value is 4. 1.5, your y value is -1.5. And 3, your y value is 16. So then you can plot those points. -380, that's like way off the chart. And you want to also imagine end behavior. So we have 3 x's, so that's an odd degree. Our leading coefficient is positive. So it's going to look just like our last one, our end behavior. So if we plot our points, again, -3, way down there, way off the chart, -1, 0. Oh, I actually have this plotted wrong. So actually a 0 is -1. So I don't actually need that here. So I'm going to find a new point. Instead of -3, maybe I'll do -2. It's still off the chart, but it's a little closer. All right, so -2 is going to be way down here, -24. All right, then I also chose the 0, and that's y value of 4. 1.5 is the y value of -1.25, so that's about here. And then 3, again, is way off the chart, it's way up here. So I'm going to, after I've determined what my end behavior should look like, I'm now actually going to draw my graph. And my end behavior resembles what I thought my graph should look like. So always double check using end behavior. So if you notice from our last graph, if we go back one page, this is a 3rd degree polynomial function, and you can see 2 directional changes. So right here, the direction changes from going up to going down, and here the direction changes from going down to going up. So we call those turning points. So in any polynomial function of degree n, the most turning points it has is n minus 1. So in a 3rd degree polynomial function, we'll see 2 turning points. And then moreover, if a polynomial function has n distinct real zeros, then it has exactly n minus 1 turning points. So we can see, again, 3 distinct real zeros. So it's going to have 2 turning points. So now we're going to use our graphing calculator. We're going to graph the function. We're going to identify the x-intercepts, and we're going to identify the points of local maximum and local minimums. So the first step, we're going to take our graphing calculator, and we're going to go to the y equals, and we're going to plug that value in, or that polynomial function in. So we're going to do a first. So x cubed minus 4x squared. Oops. All right, x cubed minus 4x squared plus 6. And then we're going to graph that. All right, so here's our graph. So this is graph A. Now on our calculator, we can identify the local maximum and the local minimum. So you'll have to go to second calc, and you're looking for the maximum. We're going to find the maximum first, so number 4. And first, see how it asks you what the left bound is? You have to scroll to the left of your maximum, hit enter. Then it asks you the right bound, scroll to the right of your maximum, hit enter, and then it's going to guess for you. And it guesses, and we're looking for the y coordinate. Okay, the maximum is going to be the y coordinate. So it guesses that your maximum is 6. So again, here's our local maximum, here's our local minimum. The polynomial function has degree of 3, total real zeros are 3, and it has 2 turning points. So we found our local maximum, 6. So we'll jot that down on here. Now we need to find our local minimum. So to find our local minimum, we can go to Calc, Minimum, and now we want to scroll to the left. Anywhere on the left is fine. It doesn't matter how close you are. Then scroll to the right of our minimum, and then guess. And now our minimum, we're looking at our y value, is negative 3.48. And then lastly, we want to find our zeros. So here's our zeros. Here's 1, here's another 1, and here's another 1. Now we could find our zeros by factoring, and then by using the quadratic formula, or we can use our graphing calculator. So to find your zeros on your graphing calculator, you're going to do a similar thing. You're going to go to Second, Calc, and number 2 is 0. So you need to scroll to the left because it asks you the left bound right here. It says left bound question mark. So scroll to the left of a 0, hit enter. Scroll to the right of a 0, hit enter, and then guess. So 1, 0 is about negative 1.09. We'll use orange for the zeros. So there's 1, 0. Now we're going to do the same thing with our other zeros. So we want to go to Second, Calc, the 0, scroll to the left of a 0, hit enter, and then scroll to the right of a 0, hit enter, guess. All right, and then our next 0, our x coordinate is 1.57. A little small, but that's this second 0 right here, 1.57. And now we'll find our last 0. So Second, Calc, 0, scroll to the left of the 0 or the intercept, scroll to the right of the intercept, and hit enter. So your last 0, 3.51. And then you'll do the same thing with the second function. Okay, now if you look at the second function, it has a degree of 4. That means you should see 3 turning points, 3 zeros, or sorry, 3 turning points, 4 zeros. And again, depending on the end behavior of your function, you'll either have 2 maximums and 1 minimum, or 2 minimums and 1 maximum. So here's what your second polynomial function looks like. You have 2 maximums. The leading coefficient is negative. You have an even degree. So here's our end behavior. Focus on that. So you have 2 local maximums and 1 local minimum. Degree is 4, 4 real zeros, 3 turning points. And so from there, you're going to use your calculator to get the value of the local maximum. That's a y value. Local maximum, y value. And local minimum, y value, and then all your zeros are going to be the x values. So you can pause the video while you solve for those, and then you can unpause for the solution. Right, so if you look at the completed table for example B, You have 4 real zeros. They're negative 1.11, 0, positive 1.25, and positive 2.86. And then your local maximum, you have 2 of them. The first one, I think this should be negative 2.03, and then 4.61. And then your local minimum is negative 1.53. And actually that should be positive 2.03 for the local maximum. So this local maximum for B actually should be positive 2, because again, we're looking at the Y values. So here's local maximum, and then here's another local maximum. And then our local minimum should be negative 1.53. So please jot down any questions you have from this lesson. Check part 2 for a story problem example. I'll do another quick video about that, but this is all that you have on your note sheets. So if you want a story problem example, again, check out part 2. Thank you. Thank you.